All right, so today's sessions are going to be a longish video, this one. So if you get a bit stuck uh, in terms of concentration, have a little bit of a break in the middle. I might give you a bit of a heads up as to when it might be a good time. All right, so we've got what's called addition and double angle formula. Addition, double angle. So addition is when we're adding angles together. Now, addition in this context includes subtraction as well, adding a negative, if you like. Double angle is when you got twice the angle. So let's have a look. Addition formulae first of all. So cosine. So in your textbook there you got a proof of this. So if we've got two angles, x and y, and if we want the cos of x plus y, then this is the relationship cos x cos y minus sine x sine y. And if it's cos x minus y, it's cos x cos y plus sine x sine y. All right, and so we put those two together. So the way we read this, because the plus is on top, goes with what's on top over here. All right, so how we can do this is we can do this with questions like the following. So it says evaluate the exact value of cos 75. Now, cos 75 is not one of our angles that we know exact values of. 30 degrees, 45 degrees, 60 degrees. They're really, other than 0 and 90, they're the ones that we know. So what we have to do is we have to express 75 in terms of those. So 75 would be 30 plus 45, wouldn't it? So because it's 30 plus 45, then what we would do is we would use, say, that cos 75 is the cos of 30 degrees plus 45 degrees. All right, and so then what we do is we go to our addition formula. So there it is, x plus y, so 30 plus 45, cos x cos y minus sine x sine y. So it's cos 30, cos 45, minus, pretty sure it's minus, double check, yes, minus on top, sine 30, sine 45. All right, now those things we know the exact values of. So the cos of 30 is root 3 on 2. All right, if you need to check that, go to your triangles. Cos 45, root 2 on 2. Sine of 30 is a half. And sine of 45 is root 2 on 2. So when we multiply that, over here we've got root 6 on 4. Over here we've got, whoops, don't need them equals, it's minus 1, which is root 2 on 4. And so if we put this together, we've got root 6 minus root 2 over 4. And so that is the exact value of cos 75 degrees. All right, so for sine, again, in your calculator, in your textbook, there's proof of this. And so sine x plus y is sine x cos y plus cos x sine y. Sine cos plus cos sine. And for minus, sine x minus y, it's sine x cos y minus cos x cos y. So sine cos minus cos sine. All right, and so we can do the same kind of thing. So find the exact value of 15 degrees. And so what we need to do is we need to express 15. And 15 degrees would be 45 minus 30. Okay, so 45 minus 30 would give us 15. So then we can say then that the sine of 15 degrees is, all right, so it is, what are we, oh, sorry, let me write that bit out first. The sine of 45 minus 30. All right, and so there we go, minus, so it's sine cos minus cos sine. So sine cos, sine 45, cos 30, minus cos 45, sine 30. All right, exact values of those we know. Check your triangles or however it is that you remember them. And remember, of course, 45 is pi on 4, 30 is pi on 6. Cos of 30 cos, there's root 3 on 2. Minus cos 45, root 2 on 2. Times sine of 30 is a half. So there we've got root 6 on 4 minus root 2 on 4, which is root 6 minus root 2 all over 4. And you may or may not notice that that's the same answer as before, and that's because we've got complementary angles there of 75 and 15 are complementary angles. 75 plus 15 is 90, so complementary angles. So their sine and cos values are same sizes but switched around. All right, that's a bit of an aside there. All right, so that's that. Now, tangent. Again, calculator, your proof is this. Now, we need to put it into 2 for tangent. We can put it into 1 like and have pluses and minuses, but it's a bit confusing if you do for the tan because there's so much going on. Also, I just thought of, you actually get these addition and the double angle when we get to them. You get them on your formula sheet, so you don't need to actually remember them, just how to use them. All right, so here we've got, there they are. So let's have a look. It says here U and V are acute angles. So before I even go there, acute angles indicates first quadrant. Just remember, acute angles are angles between 0 and 90. All right, so we know that tan U is 4 and tan V is 3/5. And it says show that U minus V equals pi on 4. All right, so U minus V is pi on 4, so what's that indicating for us to use? Tan of U minus V is what it's indicating to us. So the tan of U minus V equals, because we've got some tan values of U and V here. All right, so that's what we're going to use. So let's just shoot it back up here, the minus one. So here we go. So tan U minus tan V on top. Tan U minus tan V on top. All right, on the bottom then is 1 plus the product. So 1 plus the product, so tan U times tan V. All right, let's stick in the numbers. All right, so tan U is 4 minus tan v, which is 3/5, over 1 plus 4 times 3/5. All right, so what do we got? On the top, common denominator of 5 there. 4 times 5 is 20. And then we go, so it's 20 minus 3 is 17/5 on the top. On the bottom, I've got 1 plus 12/5. And 1, of course, is 5/5 plus 12. Let me just write me 17/5 up there. So 5/5 plus 12/5. So 5 plus 12 is 17/5. Dividing by fractions there, I believe. So when we divide by fractions, we turn upside down and multiply. So 17/5 times 5/17, I believe, would be 1. All right. So then we go back to here. Tan u minus v is equal to 1. I left myself enough time. So tan u minus v is equal to 1. And tan inverse tan of 1 is pi on 4. So u minus v must be pi on 4. All right, and remember, u minus v has to be in the first quadrant. So, of course, there's other angles. That's the reference angle, of course. There's other angles that would have a tan of 1. But initially they said that these two have to be in the first quadrant. So, therefore, it must be pi on 4, not some of the others. All right, double angle formula. So double angle, 2 times the angle. Yeah, doubling is timesing by 2. And so there's a bunch of proofs again in your textbook. All right, so if you're feeling that you want to have a bit of a break, now's a good time before I go further into this. So double angle, as I said, 2 times doubling, so cos 2x. And so it's cos x squared minus sine x squared. Now, for cos, there's a couple of other variations because we've got cos x squared and sine x squared. From our Pythagorean identity, which is cos squared plus sine squared equals 1, we can rearrange that and get 2 different things. One of them is if we take cos from both sides, you get that sine squared x, I should have, forgot my x is equal to 1 minus cos squared x. And of course, if you take sine, you get that cos squared x is equal to 1 minus sine squared x. So if I make the substitution of this first one here, so substituting sine squared x, just change the way of writing it. I just get lazy and leave those brackets out sometimes, where in this case, you kind of need them to make a bit of sense, because it's the cos of 2x, not the cos of 2 times x. But anyway, that's an aside. As I said, so equals 1 minus cos squared x. If I make that substitution here, what I end up with is that cos 2x will be equal to 2 cos squared x minus 1. And if I make the other substitution, so substituting the cos squared, so I'll go cos squared x equals 1 minus sine squared. If I make that, I get that cos 2x is equal to 1 minus 2 sine squared x. All right, so they're the variations, and you choose the one that is most useful to you in the question. All right, for sine, same in your textbook. For sine, there's only one option here. Sine 2x is 2 sine x cos x. And for tangent, here it is here, 2x equals 2 tan x over 1 minus tan squared x. And the derivation of those is in your textbook. Okay, there's a handout that I should have given you with the addition and double angle formula, and as I said, you get that on your formula sheet, both in year 11 and in year 12, unless they decide to change things. Also, there's a copy of this handout on their Google Classroom and on the website. Righto, let's have a look. So here's a couple of things that we can do. If tan theta equals 4/3 and theta's between 0 and 2 and pi on 2, so in other words in the first quadrant, find the sine and the tan of these angles. All right, so the solution. Now, what we can do here is, before we go any further, is we can first say, all right, if the tan of theta is 4/3, and we know from our unit circle, and that this relates to, and all the work we've been doing with solving equations, and the unit circle and whatever, we know that tan is opposite over the hypotenuse. So we can say, all right, if tan theta is 4/3, and here's our, let me get rid of that box there because that's right. And if here's our theta, put it down here, then the opposite to that is this side here. And so if that's 4, and the adjacent to this side here, yeah, because I've got that wrong, haven't I? That's opposite. Oh, it's sine. We're talking tan, so it's adjacent. Lucky I spotted that. Hopefully you've already spotted it. Sorry if I confused you. All right, so the adjacent's 3. All right, now, so we've got this triangle that we can use to help us with things that we need for these two. Now, if we put Pythagoras on this here, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. So Pythagoras tells us that's 5, or you can notice that that's a 3, 4, 5 triangle, Pythagorean triad. All right, blah, blah, blah. So now we're going to use this triangle to find some things. So we already know that tan theta is 4/3, and so now from that triangle we know that sine theta, using this triangle, opposite over the hypotenuse, and cos, adjacent over the hypotenuse, and so there's those. So now we can use these things when we're doing these. All right, so for A, actually that, before I move on, that's a technique here that you can use for lots of these trig kind of things. Use this. If you don't know what the angle is, you can find the sine and the cos values simply by drawing a triangle like that. All right, so A is sine of 2 theta, and that would be 2 sine theta cos theta. If you look it up if you need to. And so sine of theta is 4/5, cos of theta is 3/5, and so 2 of course is 2 over 1, and 2 times 4 is 8 times 3 is 24, and 1 times 5 is 5 times 5 is 25. All right, so the sine of 2 theta is 24 on 25. All right, so B is tan 2 theta, So let's go down here for B, tan 2 theta. All right, so when you look this up, when you go back and look this up, on the top you've got 2 tan theta, and on the bottom you've got 1 minus tan squared theta. And tan theta was 4/5, wasn't it? 4/5, yep. So on the top we've got 2 times 4/5. And on the bottom we've got 1 minus 4/5 squared. Alright, so 2 times 4/5 I believe would be 8/5. And then on the bottom we've got 1 minus 4 4s are 16 on 25 equals 8/5. Alright, 1 minus 16, so 25 minus 16 is, I believe, 9. And, hang on a second, let me see if I'm 4/3. Can't read properly, 4/3. Terrible. Sorry about that. Trying to rush things, 4/3, not 4/5. 4/3, thirds, thirds, thirds. Terrible. Okay, need to take more care than I am when we're going back. Sorry if I've confused you. So tan theta is, should have written it down there, shouldn't I? So tan theta is 4/3. All right, so 4/3, 4/3, 8/3, 16/9, 8/3. All right, 9 minus 16. 9 minus 16 is minus 7/9. Dividing by fractions, turn them over and multiply. Got some cancelling there. 3 8s are 24 over 7. All right, so make sure you double check that you're using the right values, unlike myself. All right. Okay, so I left myself some extra room if I needed it, which I didn't. All right, so these formulas we can also be used in some proofs. Now I've got 3 examples here of proofs. So if you think you need a rest before them, have a bit of a rest. So we can use the double angle formula in proofs. So here's a example of a proof that we're going to do. All right. So again, the last lesson we just did one proof, and I kind of said try and choose the one you think you can do the most with. All right, and so in this case you can use either side, but I like to use this one here, I think. Simply because I've got 2 fractions and I can get a common denominator out of those, and then I'm going to have some stuff that I can then kind of join together. So my left hand side is equal to sine theta on sine alpha plus cos theta on cos alpha. So I'm going to go for a common denominator, and the easiest way to get a common denominator is just multiply your denominators. So sine alpha cos alpha. All right, so we've got that. Now, if I multiply the bottom by, on this left-hand one, by cos alpha, I've got to do the top by cos alpha. So that's sine theta cos alpha. And over here on the left-hand one, I had the cos alpha. I'm now going to multiply by sine alpha top and bottom. So I've got cos theta sine alpha, and then I can put those things together. So sine theta cos alpha plus cos theta sine alpha. All right. And then on the bottom, sine alpha cos alpha. All right, so now when we shoot back to our sum and our double angle, our addition and our double angles, and I should have put the formula sheet up, but I didn't put the formula sheet up. That was a bit silly of me. So we've got sine cos plus cos sine. Now, sine cos plus cos sine is a sine, right? Sine cos plus cos sine, that's a sine of something. And plus in here, so theta plus alpha is what we've got there. Now, this bottom one here is very much like the sine double angle formula. And the sine double angle formula is 2 cos, isn't it? All right. So if I had a 2 here, 2 sine alpha cos alpha, if I had a 2 there, I would have the double angle. Now, I can put a 2 there provided that I multiply the top by that as well. All right. And so now when I've multiplied the top by that, so on the top here, I'm going to have this 2. And on the bottom, I'm going to have sine 2 alpha. And when we look up here, there we go. We've got now the left-hand side, right-hand side, I should say. QED. All right. So you could have started this way and gone back that way. That wouldn't have mattered. I just chose that. I tend to choose, if I've got things like 2 separate fractions, I tend to choose those and work with them. Okay, so that's the first of our 3 proofs. The next proof here it is. Proof that 1 over cos plus sine plus 1 over cos minus sine is tan 2 theta cosec theta. All right. So again, I'm going to choose to work with the left-hand side. And it's 1 over cos theta plus sine theta plus 1 over cos theta minus sine theta. And I'm going to make a common denominator of, I've got a lot of room here, have I? Of cos theta plus sine theta times cos theta minus sine theta. All right, so there's our common denominator. So over here on the left-hand one, we already had, we didn't have that, so we're going to multiply top and bottom by cos theta minus sine theta. And over here on the left right-hand one there, that fraction I already had the minus, so I need to multiply top and bottom by the plus. And so there we are with that. Now, when you expand these brackets, you can do it cos squared minus cos sine plus sine cos minus sine squared. So you end up with cos squared theta minus sine squared theta. And then on the top, all right, on the top, what have we got? We've got cos theta minus sine theta. Then this subtraction, I'm taking away all of that stuff. So I'm taking away cos theta, and I'm also taking away sine theta. All right. Except that's plus, not a minus, is it? So that's a plus, and that's a plus. Oh, nearly made a mistake. Didn't I? That's a plus there. So that's a plus. All right. So I've got cos plus another cos, which is 2 cos theta. And here I've got minus sine plus sine, so they're gone. And on the bottom here, cos squared minus sine squared, double angle formula, if you go back to those and have a look. Again, I should have brought that up. Apologise for that. That's cos 2 theta. All right. Now, what do we do from here? When we go from here, we go, okay, what am I looking for? I'm looking for tan 2 theta. Well, I've got cos 2 theta. So if I had sine 2 theta on the top, then I could combine those to get my tan 2 theta. The cosec, well, let's worry about that later. But to get tan 2 theta, I need sine 2 theta. And sine 2 theta is 2 sine theta cos theta. I've got the 2 and the cos theta, so if I times top and bottom by sine theta here, then what I've got is 2 cos theta sine theta over cos 2 theta sine theta. And the top line there, that's now sine 2 theta over cos 2 theta sine theta. All right, now as I said, the sine over cos is tan, so that's tan 2 theta times, now the sine's on 1 on sine. Now 1 on sine, that's the reciprocal, which is cosec. All right, so the cosec kind of sorted itself out in the end. We didn't have to worry about going back and trying to create that by multiplying top and bottom or common denominator or something like that. That's sorted itself out. So we've got that what we're after, and so that equals the right hand side, QED. All right, one more. Now, this next one is quite complicated. So we're going to have a lot of fun with this next one. So prove that sec A minus cos A times cosec A minus sine A is 1 over tan A cot A. All right. Now, sometimes we're going to have to do what we're going to have to do with this one here, and that's adjust both sides. Now, we do that independently. All right, so remember I said last lesson, where we're proving that this equals this. We can't make assumptions, so we can't go flopping things from one side to the other. Got to work with one side at a time. And so the left-hand side, let's start with the left-hand side, which is sec A minus cos A cosec A minus sine A. All right, so what I'm going to do is multiply those out using FOIL. So we've got sec A, cosec A, sec A, so minus sec A, sine A. Then we've got minus cos A, cosec A, and a minus times a minus, it's a plus cos A, sine A. All right, we've got that. So we need to probably do our reciprocals. So sec's 1 on cos times 1 on sine minus 1 on sine times sine. Right. Oops, no, that's not right. 1 on cos for sec. And then minus cos 1 on sine for cosec plus cos A sine A. All right. So what do we got? We've got 1 on cos A sine A minus sine on cos minus cos on sine plus cos A sine A. All right. Question is now, what do we do about this? Got to combine all of these things together somehow. Common denominator, cos A sine A. First one's already good. Whoops, not equals, minus. The next one, cos A sine A. The cos A was already there with times by sine A, so top times the top by sine A. Got sine squared A. Minus cos A sine A. Sine was already there, got to times the top by cos A as well, so we've got cos squared. Plus well, this one was over 1, so we got cos squared A and sine squared A on the top. Righto, what can we do here? Well, what we can do here is this. We can say, all right, 1 cos A sine A. Take the negative out and put these two together, and we've got sine squared plus cos squared over cos A sine A. Now, sine squared plus cos squared is equal to 1. So effectively here we've got 1 over cos A sine A. there like that. Now we've got 1 over that minus 1 over that, so there you go. Just leaving us with this bit on the end. Okay, so this bit on the end, I've actually done some work there that I actually didn't need to do, because now we've got cos squared A sine squared A over cos A sine A, and they cancel out, but I didn't know up here that that was going to be the case. I was just going to put it all together and see what happened. So one of the coses cancels, so now we've got cos A, and one of the sines cancels sine A. And so now we're stuck. We still haven't got to this. So in this case, what we need to do is go, okay, so our left-hand side, when we simplify it, is equal to cos A sine A. Now what we need to do is we need to go to the right-hand side. And I'll go, okay, so their right-hand side, and that was 1 over tan A plus cot A. And so what we need to do here with this is we need to, well, write what tan and cot are for a start. So we've got 1 over. So tan is sine A on cos A, plus there looks like a bit like a times, it's a plus. Cot, which is cos over sine. And now on the bottom here, what I'm going to do is I'm going to say, still 1 over. Let's make a common denominator here of just the multiply of cos A sine A. So over here, top and bottom by sine A, so sine squared. Over here, top and bottom by cos, plus cos squared A. Now, sine squared plus cos squared is 1. So it's 1 over cos A sine A. And we're dividing 1 divided by a fraction, turn upside down and multiply. And so we get cos A sine A, and then we compare that to what we got up here, and we got the same thing up here. So that is therefore equal to the left-hand side QED. All right, so there we go. We had a bit of fun with that one. I went through them kind of fairly quickly, I suppose. So if you didn't follow, go back. Of course, I know some people pause for a little bit during, just to get their head around what's going on. Sorry about those few little arithmetic errors and things that I did in there. Hopefully they didn't confuse you. If they did, make sure you get some assistance to sort out and clarify anything. And as always, have fun.